All right, so rolling back deployments is one of the advantages of the other advantages over replica sets. So let's describe our current deployment to see where we are. And we are currently version blue. So version blue it is. So we change it to green. And we apply the deployment. Which means this will take a second, but we should but we should see that the version is green now. Now if you want to undo the deployment, roll out undo deployments, name of the deployment, and we'll go back to describe the deployment. Then we have blue again. So again, here we specify green. We deployed green. We got green. We rolled back. We rolled back. And now we got blue again. So because it stores the definition of the old replica set, it's rather easy to go back to a previous application state with a single command. This is especially handy if during the deployment of your deployment you find that unforeseen circumstances occur and that your application deployment is failing and you want to go back fast or quickly. So yeah, deployments are providing you with means of updating your application services. It gives you much control over the way it does that. You can scale the deployment with the number of replicas, just like with the replica set, which is basically what it does underneath the hood, is using a replica set and scaling that replica set. We have seen that it is possible to have rolling upgrade strategies and a replace strategy. The recreate strategy, which is the precise name, means that you'll switch off a replica set before replacing the replica set, which takes a longer period of time and also creates a service downtime. So service here referring to the application, not to the Kubernetes service. The second strategy, which is the default strategy, is the rolling update strategy. The constraint of that strategy is your application needs to be able to tolerate 2 application versions running simultaneously, which is not always the case. It requires additional engineering effort, but if you go down that route, you have the advantage of a very, very small amount of service impact. We have seen that by using our curl loop, that only a single request has failed and that the service impact was rather minimal. We have now seen that you can roll back and undo deployments because the deployment actually keeps track of the history of deployments. We have seen that you can retrieve a history of deployments, and yet you can go back in time and pick the one you'd like. All right, so there's obviously more to say about deployments than we can cover here in a first iteration learning Kubernetes. But what we've learned so far, what are containers, what are pods, how to create a pod, what is a replica set, and what is a deployment. It already provides you with the foundation work to deploy your first applications. Now, the next thing is, it is very likely that your application does have configuration values and maybe uses passwords, credentials in general, username, passwords, certificates, and so on. And you don't want to make that a particular part of your application code because then you cannot serve different application deployments with one from one code base, which is one of the 12-factor rules So we can go to 12factor.net, where the 12factor app is described, which is a very good best practices for creating web applications. So if you are new to writing web applications, you should definitely read the 12-factor manifest. So one code-based tracked and revision control many deploys. This basically means that you should not enter the externally facing domain to your application code, because it is defined in an ingress, and the ingress is specified in a YAML file. It's not part of your code base. It's not in your Go code or in your Ruby code or in your Java code or anything like that. So we need to find a place on where to store these configuration values, and also configuration values like passwords that are more sensitive than arbitrary configuration values. Kubernetes has a concept built in. It's called config maps and secrets.